A list mode vector is still a vector in that every element is the same data type, and that data type is whatever the computer needs to keep track of another location in memory. Because it doesn't care about the type of that location in memory, that means each element of the list can be any type of data that you want. So if we go to an R session, I'm going to make a new list, call it Y. Each element of this list can be an atomic vector of any type that I like. So I could do a numeric vector in the first element. I could do a character vector in the second element. And I could do a logical vector in the last element. So if I look at Y, again, I'll have these double square brackets indicating each element of my list, 1, 2, and 3. We can see that the first one is a numeric vector with 3 values in it, 1, 2, and 3, starting at an index of 1. The second vector is a character string vector with an A and a CD as the 2 elements, again starting at 1. And finally, true, false, false, true in terms of vector of logical values in the third element. We can use the type of to make sure we understand what's going on here. So if I do a type of on Y, it's just going to give me a list mode vector. That means it's a vector of references to other objects. But if I start using my double square brackets to look at the contents of Y, well, first of all, let me use the single square brackets and say, well, let's look at element 2. Remember, if I use the single square brackets, it's just going to return another list. It's going to have one element of it, but it's still going to be a list. And we can tell that because there's a double square bracket here. And also, if I did a type of on Y2, I'm still a list. If I use the double square brackets, however, of element 2, oops, I forgot the Y, then this is going to give me the contents of the second element, and that is going to be a character vector, or a vector, atomic vector of character values. And again, I can do Y2 with double square brackets, oops, to see that it is indeed a character vector with A and CD in it. I can do the same thing with the other elements of the list. A type of on Y element 1 should give me a double precision floating point atomic vector, and a type of on the third element of Y should give me a logical vector. Hopefully this gives you a relatively simple example of how to use list mode vectors in R to combine relatively simple data types into a more complex data types. Ultimately, lists are vectors of what other languages call pointers, or pointers to other location in memory. The indirection you get from pointer-like data structures is the heart of building hierarchical data structures, which we'll get into later in the class. But it's also, if you get further into using pointers in computer programming, it's central to how we make our programs extensible, or how we program plug-and-play software. That's not really the central to this course, but indirection is central to that effort in software engineering.